Hello there, welcome to my class. Today we'll talk about...
Hello everyone, let's deal now with the difference between that of a bipolar junction transistor and a field effect transistor. Bipolar junction transistors are considered to be current control device. Why is that so? Current control device because the current at the output which we are trying to control is dependent on a current at the input. Taking for example, this one, the current at the output IC is dependent on the current at the input IB. That's why the relationship of IB and IC, which is defined by one of the parameters that we are using, which is beta, is equal to IC over IB. With respect to field effect transistor is considered to be a voltage controlled device. Why? Voltage controlled device because the current ID in our output this time is dependent on an input voltage which is VGS. This relationship this time is defined by our Shockley equation. ID is equal to IDSS 1 minus VGS over BP quantity squared. With this, we can see that the current at the output, which is ID, is being controlled or is dependent upon a voltage VGS, which is at the input. As we try to look at the illustration of a junction field effect transistor here. The current ID, which is also that of IS, is being controlled by a voltage between the gate and the source. You might be saying, but there are other parameters that we can see on the equation, that is IDSS and VP. IDSS, which is our saturation current, and VP, which is our pinch off voltage, are not applied voltages. Rather, these two parameters are dependent on the characteristic of the field effect transistor. It's never an applied voltage which we are going to use to control the current ID. Number 2, we say that a bipolar junction transistor is bipolar, whereas that field effect transistor is unipolar. Field effect transistor is considered to be unipolar because that part of our transistor where the current will flow is a single material. It's either N or a P. This material connects the drain and the source. Let's deal with that of the bipolar. In our analysis before, we know that the current will flow, for example, from the emitter going to the collector. With that, it passes through a P material and an N material, and it therefore passes into two material. Therefore, we call it bipolar. Another that we have to look into is that we say that the current IB is approximately equal to 0. Why do we say so in bipolar junction transistor? Because the value of IB is in microampere, while the value of IC and IE is in milliampere. The equation for IE, which is equal to IB plus IC, will be approximately equal to IC if IB is equal to 0. That's why we have IC approximately equal to IE. These conditions before in our analysis in bipolar junction transistor. In contrast, field effect transistor, the current at the gate is equal to 0. Why? The gate is isolated. It has insulating materials used in our transistor. With that, there is no current that is flowing into the gate. IG therefore is equal to 0. Since the drain and the source is connected directly to each other to a single material, the current therefore that is passing from the drain into the source are equal. Not like in our bipolar junction transistor. Considering for example IE and IC, it does not directly pass from emitter going to the collector, but it passes through our base. That's why looking into this, in entering current IE and the current that are leaving is IC and IB, that's why we said IE is equal to IC plus IB. Not so with respect to field effect transistor, where the current at the drain passes to a single material going into the source, therefore the current ID is equal to IS.